Aloha and welcome to our video on folds, faults, and mountains. In here we will discuss the types of folds, the types of faults, we'll describe folded mountains and fault block mountains, and we'll finally describe plateaus, domes, and basins. Okay, a little bit later on in this course, we're going to discover that sedimentary rocks like to lay down in layers horizontally. And when they're undisturbed, that's how they're going to remain. But when we apply forces, we can cause these layers to become disturbed and they no longer have that flat look. They kind of get buckled. It's kind of like if you took a piece of paper and you pushed the edges of the paper together, it would kind of bump up like that. And that's what we notice happens with these rocks. When we call these rocks, when they're doing this, we call this a fold. Now, two types of the folds that we're going to talk about are an anticline and a syncline. Anticlines are folds where it kind of curves upwards. Synclines are the opposite. That's where it curves and comes downwards. And normally these are going to be in conjunction with each other. That means we'll see anticlines and synclines. And you can see how it lines up if we look. We have an anticline, a syncline, anticline, syncline. The third type of fold is what we call a monocline. And a monocline is kind of where we have a little step. So if we look here, we can see how it kind of goes and it steps down like that. And that's what a monocline is. So it's not a curve upward, it's not a curve downward, it's just kind of like a little step, and that would make it a monocline fold. Okay, so when we apply these forces to these rock layers and to these plates, occasionally they break. And when they break, we call that a fault. And there's several different kinds of faults, and we're going to go through those real quickly. The first one is what we call a normal fault, and it's caused by tensional forces. And if you can recall, tensional forces are going to kind of stretch this apart. So as that happens and we break here, you'll see that the hanging wall is going to slip down primarily off the footwall. We're kind of pulling it apart, and that allows it to slip down a little bit. And that would be a normal fault. Okay, and the opposite of a normal fault is what we call a reverse fault. A reverse fault comes from compressional forces, and that's where we're going to be squeezing these rocks together. And as we do so and we get a break, then we can see that this hanging wall is going to be thrust up and over the footwall. So it's the opposite motion, and that's because instead of pulling them apart like we did in a normal fault, we're squishing them together in a reverse fault. Now the angle of the fault is really kind of important. If it's a steep fault, we call it a reverse fault. If it is a shallow or almost horizontal one, then we call it a thrust fault. A thrust fault also has these compressional forces, so it's being squished together, but here you can see that the fault is going to be a very shallow angle, and because of that we call it a thrust fault. And finally, we have a strikeslip fault, and this is caused by shear forces. And you can see how the upper block is going to be thrust this way, the lower block is going to go the other way. And now notice that we don't have any going up and over like we did in the other faults. These are kind of more side-to-side faults. And these ones here is where you would see, like if we had a road, the road would be here and it would show up here, and you'd see how it was shifted over when we had that earthquake. Now, if we have a lot of these compressional forces going on here, what we can do is we can build up a bunch of folds over time, and that'll get us folded mountains. And folded mountains, if you looked at the rock layers, you would see that we would have these folds inside. And you can see an anticline and a syncline over here. And you're just seeing it's basically if we took this mass of continental crust and squished it in together, that it would buckle and fold, and that's what would give us our folded mountains. Okay, just like if we have excessive compressional, we can also have excessive tensional stresses on this crustal mass. And as that happens, you'll notice we're pulling it apart here, and that's going to cause an awful lot of faults going on down here. And that'll cause it to break, and we end up with these blocks, and that's why we'll call them a fault block mountain system. Now, a couple terms you want to be familiar with in the fault block mountains. We have the horst, which is the upper part of the mountain, followed by a little basin looking thingy like a graben there, and these are going to run parallel. Okay, so this is when we talk about basin and range area. Here we have our ranges, and then we'll have our basins as well. Now, some other formations that can be caused by these internal forces would be like a plateau, and that's where we have a high elevation level surface. That means that the whole area was just lifted up. We can also have a dome, which we're going to see an upwarped angle, and you can see that down here where we're seeing this upwarping, and that's going to form a little bit of a dome. Generally, they're going to be circular. We can also have a basin, which is where it's going to be coming down and squished like that. And you can see that they can be quite large, but they're going to have that circular shape as well. Okay, well, the lesson will go into a lot more detail than I did here. I just wanted to introduce it to you. Good luck on your lesson and your quiz, and we will see you in the next video.